In this series, I'll show you how to write decentralized applications using normal programming languages that you already know, like Python. That means you don't need to learn Solidity, you don't need to pick up a new language, you don't need to be an expert blockchain developer, and you can very quickly write decentralized applications that are Web3, that are running on a blockchain network like Ethereum, and you can use your existing Web2 knowledge to do that. So whether you're a Python developer, JavaScript, Go, C++, doesn't matter. This video specifically in this series will be focused on Python because I know many of my viewers know Python, but you can do the exact same thing in really any language so long as it runs on Linux. Now, the way we're able to do this is by using a framework or library known as Cartesi. Now, Cartesi is the sponsor of this video and this series, but don't worry, they're completely free. You don't need to pay for anything. They don't even take any money from you. And the reason why they sponsored this is they want me to show you how game-changing this technology is and to try to get some more people into Web3 because they've completely removed the barrier of entry, which is learning Solidity and picking up this whole new paradigm, which can take a really long time. So with that said, let me give you a quick demo of exactly what we're going to build in this series. Then I'll talk more about exactly how this works and what you can expect for the rest of the videos. Alright, so I got a quick demo running on my computer, and I want to remind you that to build this, I used no Solidity. On the right hand side of my screen, I have a Python backend. That's right, normal Python code that you would be able to read. And on the left side, I have my front end, which is written in JavaScript and React. Now, we'll build this exact thing out step by step, but I just want to show you how it works and give you a sense of the features we're going to build. I know it seems a bit simple because this is going to be a rock, paper, scissors challenge game, but I promise this is a really great introductory project, and it will kind of lay the foundation and give you those core skills so you can extend this and make it a lot better, a lot cooler, and build some other decentralized apps. So I'm signed in with MetaMask, and I'm connected to kind of a demo hard hat node, just running on my local host. We don't have this deployed out, but we'll talk about that later in the series. Now, what we can do here is we can make challenges. So you can see that I can click rock, paper, scissors, and I can make a new challenge. Now, I already have one active because I just made one, and it says my move is currently hidden, challenge number 0, and we're waiting for someone to challenge us back to play rock, paper, scissors against. So what I'll do is I'll go to MetaMask. I will change my account over here, so let's connect to this one. Refresh, and now you can see that we have a challenge. This is the opponent, the move is hidden, and we can challenge them. So I can choose maybe scissors and click on challenge. Okay, and I'm going to go ahead and click confirm. Now notice the important thing is that one player made a challenge, they submitted their move, but I'm not able to see what their move is until I make my own move. Now, we'll talk more about this in the series, but this is a cool kind of feature we're adding here to show you how to securely transmit data in an asynchronous manner to the blockchain such that you can hide it from a third party. So you can see that as I do this stuff, we're getting some, kind of feedback here in the console or in our backend. So just keep that in mind. Now, if I update the challenge, we have an active challenge and both players have moved. Now that both players have moved, what we can do is reveal our move, and as soon as both players reveal their move, then we will have a winner for the challenge. Now, we're not revealing it until both players have made their original move, so no one can cheat in this process. So if I click on reveal move, we'll go here and we'll send our transaction. Just give this a second here, it should pop up in the console. Okay, so it says adding notice, this player has revealed their move of scissors. So if we update the challenge now, it says our move is scissors. We're waiting on our opponent. And if we go here and we switch back now to the opponent, which is player 6, and we update the challenge. So let's refresh the page here. You can see it says the opponent move is scissors. Your move is hidden. If we want to see who wins, then we can go ahead and reveal our move. So let's do that. Give this a second for it to pop up in the terminal here. Okay, so you can see it says this player has revealed their move of rock. And if we update the challenges, it says we won because we had rock, the opponent had scissors, and there you go, that is challenge 0. Then we could go ahead and make a new challenge if we want to. So we can make a new one where we choose rock. Okay, we'll see if that comes in here. Give this a second. Okay, challenge ID created, update challenges. We now have a new active challenge, and we can go through this whole process. So anyways, that was kind of the demo of the application. Just to give you a little sneak peek here, you can see that if I go in this main.py file, this is the whole backend that's running this application. Okay, it's about 200 lines long. There's a few other files as well, but this is all written in normal Python. No Solidity code, no complex stuff that you don't know, only code that you've written before and that you've seen. Really, really cool. I can't wait to bring you guys along for this series. Let's now hop over and talk a little bit about the prerequisites and some more stuff that you need to know before we get started. All right, so before we go too much further, let me just break down a few key terms that you're going to want to know before we go forward. So first, what is a decentralized application? Well, this is really some kind of application that runs on typically a peer-to-peer blockchain network, think Ethereum, Bitcoin, whatever, that is decentralized. Decentralized means there's no central authority or someone controlling it. It can't just go offline, it can't just be deleted, it can't be tampered with because of the security kind of features of a blockchain network. So for example, a bank, right? This is the best example we have of a centralized kind of entity. If I were storing money with a bank, at any point in time, if the government doesn't like me, if the bank doesn't like me, they can freeze my assets, they can take my money, my account could be deleted. There's a central figure or authority or multiple that have control of my account. A decentralized application is the complete opposite. Once your code is hosted, once it's live, no one can go and tamper with that. No one can change it. No one can modify it. It's there. It exists. It's trustworthy. And that's kind of the major feature of a decentralized app. We have trustless communication because of smart contracts and ways that we can interact with each other on these blockchain networks. Now, when it comes to building these decentralized applications, there's many different ways to do this. And the first way would be to do this just directly on the blockchain network. If you've ever written a Solidity smart contract before, you just deploy that to Ethereum, and what this means is you're actually using a layer 1 solution, or a layer 1 technology. Ethereum, Bitcoin, any base level blockchain network that can operate independently of anything else is what's known as layer 1. Now, layer 2 is something that's on top of a base level blockchain network. It relies on the security features of that network, but it aims to improve some of the speed, scalability, efficiency, etc. of that base level network. So something like Ethereum can actually be incredibly slow and it can be incredibly expensive, especially if you want to do a lot of operations, you want to have a lot of code running, you want to even just have a simple decentralized app like the one that we have. If you're running that directly on Ethereum, it can be quite expensive. So what we actually aim to do is take some of the transaction load and some of the computations off of the base level network to a secondary network known as our layer 2 solution, right? And then what we'll do is we'll utilize the main security features and benefits of layer 1 to keep our application secure. We'll kind of offloading some of the heavy, expensive, and time-consuming computation to layer 2. This is a gross oversimplification, and I have some videos that go into this more in depth that I'll leave on the screen and in the description. But when you think of layer 1, think of your base level network. And when you think of layer 2, think of on top of that network, which aims to make things faster, cheaper, etc. by kind of offloading some of that heavy computation, but still relying on and utilizing the security benefits of layer 1. Now, a great example of a layer 2 solution you probably know is something like Polygon. This sits on top of Ethereum and it increases the transactions per second. Now, what we'll be using here is something known as Cartesi. This works quite a bit differently than something like Polygon, but this is a layer 2 solution, sits on top of a blockchain network, and it really just takes all of our heavy computations and execution, takes it off chain, and then does it in a verifiable and provable way and reports all of the results on chain. We'll get into the architecture later on, but what you need to understand for now is that Cartesi uses something known as optimistic rollups. I have an entire video that breaks down what those are, so I'll leave that in the description. But what this really means is that we utilize the blockchain for reporting all of our transactions or kind of state changes, which we'll get into later. We then do all of the heavy computation off-chain in a verifiable manner, and then we report it back on-chain. That way, at any point in time, we can actually check what's gone on. We can see a log of all of the different transactions, but they're condensed, they're compressed, and we're taking all of that heavy work that usually costs a lot of gas and money, and we're just taking it off chain so that we can do everything a lot more scalable, a lot faster, and just a lot more efficiently than if we did it directly on the Ethereum main network, which, as you know, can be congested, expensive, and slow. So this is in contrast if we just wrote a normal smart contract. A smart contract is something that is deployed directly to the Ethereum main network, and this means that anytime we want to do any work in that smart contract, we have to utilize the Ethereum chain, which means we're paying a ton of gas fees, we're paying validators, we're paying all this kind of stuff, and we're doing quite a bit of work. And doing any computations on a blockchain, storing any kind of data is very, very expensive, so that's why we take it off chain. We'll talk more about this later. Don't worry. Now, this all sounds great, but there's still a lot of issues with traditional blockchain development, which is how people have been doing things kind of up to now. So if you want to write a smart contract, which is really the code that facilitates kind of trustless interaction on the blockchain, it's difficult. You got to learn a new language, and there's quite a few limitations to what you're actually able to do. Solidity is a good language, but it's very difficult to understand for someone who's new, and there's just quite a few limitations. For example, anytime you want to perform executions or computations on the blockchain, you need to submit gas. Gas is essentially a payment to whatever the node is that's actually doing all of these computations. Now, there is a gas limit. This gas limit is not that large, and that actually means that if you wanted to do something as simple as 1,000 loops, okay, you want to add a number 1,000 times, you could very easily run out of gas. You can actually not have enough gas in one transaction to complete the computation that you want to perform. So you think of huge computations that require maybe a few minutes to run, it's impossible to do those in one transaction. You'd have to batch them into like 20, 30, 50, 10,000 different transactions, which would be extremely costly. Now, as well as that, there's a lot of features that just don't exist on the blockchain network itself. Things like floating point numbers, very, very difficult to implement and utilize on the network. You want to get the number pi. Next to impossible, again, to actually have that on a blockchain network. You want to use familiar tools. You want to use math libraries, physics libraries, data structures, and algorithms. Good luck building those in Solidity and utilizing them on the blockchain network. There's quite a few limitations when it comes to the coding side. If you've ever worked in Solidity, you would have seen that before. And that's why with a framework like Cartesi, we're going outside of the main network, performing computations off-chain and allowing ourselves to use anything that we've used before. We can use our math libraries. We can use floating point values. We can use regular lists or dictionaries, objects, classes, methods. Anything that you've used in standard programming before, you can go ahead and use it, and we can still write code in a verifiable and trustable way where we're utilizing the main security features of the blockchain. So that is kind of why traditional Web3 development really hasn't taken off yet, because there's so many limitations with it. And as soon as you start trying to build anything complex, you realize, damn, this is going to be way, way harder than it would have been if I did it in a centralized manner using kind of a normal server, normal web app, whatever. So a lot of people just don't bother building these decentralized apps, or if they can build it, it takes a very long time and it's very, very challenging. So I'm really excited about the next kind of phase of Web3 where we have all of these great frameworks and libraries that are making things easier, like Cartesi, and I'm going to show you in this series exactly how we use it and how it works. I know it's going to impress you. Now, just as a last few notes here, some basic prerequisites for the rest of this series, because in the next video we're actually going to get into some setup and code. You should have some familiarity with Python. You should have a little bit of knowledge of how blockchain networks actually work. If you don't, I will leave a link in the description to a series that can teach you everything you need to know. If you have any understanding of Ethereum's JSON RPC API, that's going to be helpful. If that's a bunch of gibberish to you, don't worry, you'll still be able to follow along. If you have any experience with Docker, that's going to be helpful because we will be using Docker. But again, if you don't, I'm still going to walk you through the process step by step. Now, if at any point you're getting stuck, you're having issues, troubles, you're frustrated, I will leave some support channels in the description that you can reach out to. These are directly with Cartesi, like Cartesi's Discord server, where you can go in there and you can get support, one-on-one help. Any issue you have, you can ask them. They'll help you out to the best of their ability. And that's how we're going to make this series really easy for everyone to follow along with. Anyways, I hope you guys are excited. I know this video is kind of a lot of theory, demos, etc. This is a new thing, so I just want to make sure I take my time, walk you through it step by step. In the next video, we're going to get into a setup. You're going to see exactly how this works, how we write this decentralized app with normal coding, how we interact with it, how we get our environment ready to go, and then the next few videos will actually be building this DApp. We'll go through the different features, and you'll slowly start to get the hang of it, so by the time you're at the end of the series, you fully understand how this works, and you are ready to build DApps in really any normal programming language you already know.